In early April 2026, a very specific hardware configuration quietly vanished from the internet. If you clicked through to buy a Mac Mini with 32 or 64 gigabytes of memory, the page didn't give you a shipping date. It simply grayed out the buttons and told you the machine was currently unavailable. For the flagship Mac models that you could still add to a cart, the delivery estimates began stretching out to 16, 18, and sometimes 20 weeks. Buyers suddenly found themselves waiting up to 5 months for a computer. Apple built its entire modern reputation on crisp logistics and on-demand fulfillment. Running out of standard hardware configurations and leaving buyers stranded for months is wildly out of character for the company. Yet the company has maintained absolute silence. There are no press releases explaining the delay, and nobody offered an apology to shareholders about missed hardware sales. The machines simply disappeared. This gap in the catalog marks the moment a massive, invisible reallocation of tech resources finally collided with Apple's storefront. In early 2026, an open-source project called OpenClaw went viral among developers. It lets anyone run an autonomous AI agent locally on their own computer. You talk to it, and it can read your email, schedule your calendar, and actually do things without sending your data to a corporate server. This chart shows the raw economics driving the trend. Running a highly capable AI agent through a cloud API costs a user a couple $100s a month. Running that same agent locally costs about $2 a month in electricity. The catch is the hardware. To get cloud-level intelligence, you need to run a large 70 billion parameter model, and a model of that size needs to live inside 40 to 50 gigabytes of fast memory while it thinks. Building a traditional PC for this hits a wall. You need a workstation-grade graphics card for $5,000 just for the video RAM, and you still have to shove all that data back and forth through a narrow connection to the processor. Here, Apple's unified memory architecture became highly relevant. On an Apple Silicon Mac, the processor and graphics engine share one massive pool of high-speed memory. The data never travels. A $2,000 Mac Mini with 64 gigs of RAM runs a massive AI model flawlessly. In early April, a major cloud provider suddenly banned third-party frameworks like OpenClaw from running on its consumer tier. Thousands of hobbyists moved their setups local immediately, and they knew exactly which machine to buy. Apple accidentally engineered the perfect, cost-effective engine for local AI execution. Within just a few days, a massive customer base the company never planned for completely wiped out their entire high-RAM inventory. But a spike in hobbyist demand alone doesn't explain a 5-month shipping delay. When a product goes viral, a logistics machine like Apple catches up in a few weeks. Beyond the immediate demand for home servers, a much larger pressure is building at the start of the supply chain. Nearly all the world's memory is manufactured by just 3 companies, and those facilities have aggressively shifted their production lines toward enterprise AI. Specifically, they are printing high-bandwidth memory, or HBM. This specialized memory is built to sit next to NVIDIA processors inside massive data centers. This visualization breaks down the math of why the entire industry pivoted. Fabricating a single gigabyte of HBM takes up roughly 4 times the physical silicon wafer space of standard memory, but the profit margins on it are 3 to 5 times higher. Look at this graph of consumer memory prices. Because factory space is now dedicated to enterprise data centers, standard memory is experiencing a structural shortage. Industry insiders call it Ramageddon. In a single month, certain memory costs spiked 75%. Apple isn't delaying the Mac Mini by choice. They physically cannot source high-density memory modules because the global supply chain has reallocated its resources to feed NVIDIA. There is also a standard industry cycle to consider, the transition to the next generation of Apple Silicon. Rumor watchers point to the upcoming M5 processor launch at June's developer conference. It is common for hardware companies to stop producing top-tier configurations right before a new release, so they don't sit on outdated inventory. But removing the 32GB Mac Mini doesn't fit that pattern. That specific model is a standard choice for developers and creative professionals. Pulling it off the shelf months early serves zero strategic purpose, unless you are lacking the parts to assemble it. The M5 refresh offers a convenient public relations exit. It allows the company to let inventory drain out quietly, raise prices on the new models, and never openly admit that they lost priority in the global component market. If you just want to buy a mid-range computer right now, your options are bleak. You either accept the base models that are still in stock, pay a severe premium to resellers, or wait indefinitely for the supply chain to correct itself. For 2 decades, computer memory was just a cheap, predictable commodity, but today it is a contested strategic asset. Tech giants like Meta, Google, and Amazon are on track to spend $650 billion on hyperscale data centers this year. When hundreds of billions of dollars flood into a single sector, the surrounding infrastructure inevitably warps to accommodate it. The result is a bizarre market collision. A small business trying to buy hardware to edit video is now unwittingly fighting for the exact same physical silicon wafers as trillion-dollar tech conglomerates. The computer you need for your daily work is sitting completely sold out on a corporate website because someone thousands of miles away realized it's the absolute best machine to quietly run an autonomous intelligence in their spare bedroom.